Amrita, if you're ready, we're going to go ahead and get started. So welcome to our privacy seminar, which has been running for the past 12 years. It's a weekly seminar. As I've mentioned, with all the microphones in the room, you might hear some people chewing on their pizza today, but hopefully that will not be too much of a distraction. These are very engaged attendees who are all very much studying and working in privacy. And so I think that you're going to find that you've got an audience that's really, really interested in what you're talking about. So for those of you who don't know her, Amrita is got her education at Stanford. She's now working in privacy at Meta. And today's talk will be focusing on this key concept of purpose. As you know, increasingly regulations have been looking at restricting the collection and use of data, and purpose is a central part of that. And obviously one of the challenges that she's going to be talking about is as data flows and gets passed from one entity to another across various elements of functionality, how do you ensure that those purpose commitments that perhaps are being made at the time of collection, hopefully are made at the time of collection, continue to be properly respected. And so I assume that this is what she's going to be talking about, and how do you do that at scale in the context of privacy-aware infrastructure. So Amrita, we're all really, really excited to have you here today. And at this stage, we're going to ask our camera person to switch the screen, and please, take it from here. Very much looking forward to your presentation.
Thank you so much for the introduction. It's my pleasure to be here and to be talking to so many people who are actually interested in this space. Today, I'm going to be talking about, as was mentioned earlier, purpose limitation at scale with privacy-aware infrastructure. That's a mouthful. And I'm actually pleasantly surprised that there's already a lot of context, I feel like, in the crowd, at least with the way I was introduced. So I'm really excited to get into the context of the talk today. It's also nice to see people having lunch. It does look really good. So I hope I provide sufficient entertainment over your lunch.
Thank you. I'm sure you will.
Cool. So my name is Amrita. I'm a software engineer at Instagram Privacy. I've been at Meta close to a decade now. I've spent the last almost 7 years in the privacy space, and out of which I think the last 4 years has been dedicated to working on purpose limitation. Purpose limitation isn't the only thing that we work at on Meta and privacy. So if you want to talk about other opportunities, I'm always available to chat as well. So in today's talk, we'll talk a bit about what is purpose limitation, what are some of the key challenges that we face over here, the approach that Meta has chosen to take, and finally, we will talk about policy zones. So policy zones is at the center of how we have decided to approach purpose limitation and how we're able to enforce a lot of our privacy requirements at Meta scale. So without further ado, let's jump in actually into the content today. So what is purpose limitation? So Meta has a lot of privacy requirements. Many are related to purpose limitation. As I said earlier, purpose limitation is not the only area that we focus on, but increasingly there's been a lot of scrutiny on how data is being used. And as the world is getting more and more digital, everybody's sharing a lot of their personal information. It becomes very, very important that the data is only used for specific purposes that the user actually intended when they shared the data with different platforms. So purpose limitation means to ensure that data is not used for purposes that it was not stated for, or that it is used only for the stated purposes. So depending on the requirements, it can be put in the positive of like is only used for particular reason or is not used for some other reason. You can also Google on what purpose limitation is. And as mentioned previously, there are a lot of regulations in a lot of different countries that focus on this. So there's GDPR, I think, which is the highest standard today, on which does a pretty comprehensive worldview of what should be included in purpose limitation and data use. And then you also have a lot of FTC work over here that specifies what is acceptable and not. So if you just Google for it, you'll get a lot of examples of cases where we see why this is very, very important and pertinent. So even if you want to go look at GDPR's definition, purpose limitation means that personal data can only be collected and used for specific, explicit, and legitimate purposes and cannot be further processed in a way incompatible with those original purposes. So let's look at some toy examples. So let's say our privacy requirement is banana data is only used for smoothie making purposes. This is a positive way of putting a privacy requirement, but this is actually a stronger requirement than the negative version. In this case, we're saying that banana data cannot be used for anything else. It can only be used for smoothie making purposes. Sometimes we have a less strict version of the requirement, which is phrased in the negative. Banana data is not used for bread making purposes. So in this example, we're saying that banana data is collected and it specifically cannot be used for bread making purposes. This is, as you can see, slightly more relaxed in the sense that we're saying bread making is what cannot use this particular data. Other things it depends on the context that we have to be evaluated on. So with that, let's get to the challenges that we have faced in solving purpose limitation. So there's limited prior art in the industry because this, as we've mentioned, while there is a lot of scrutiny in the recent past, there hasn't always been such large amounts of data available. And now that it is available, it's not very easy to figure out how we want to and do not want to use this data. And there's not too many places that have done anything at this scale. Speaking of scale, Meta has like a huge number of employees, a large number of systems, very high throughput systems, so many languages, frameworks, and in between all of this, we have to go and plug in purpose limitation retroactively. And then there's also the granularity of representation. The data is not always cleanly available in nice chunks. It's in like, sometimes it's in a small part of an existing database or a small part of a code and so on and so forth. So let's look at each of these with a little bit more detail. So rolling out purpose limitation on existing code and systems is fairly novel and does not have established techniques. So existing privacy controls at the company and even in the industry solve the problem of who can access data. You have technologies like auth tokens, user identity, and ACLs, and these do quite well and have been around for years. They prevent one user from reading the private data of another user. Or you can even think of it as like system levels. Can this external service access this specific data? So they are pretty good at what they do, but they're not very good at purpose limitation. What do we want for purpose limitation? We want to make sure what can be done with the data or where can the data go. This is completely different from what the existing technologies do. And for this reason, we've had to think about newer ways to solve this. Even if we look at an example, my phone is sending out hundreds of requests to Meta servers, and it's for a variety of purposes. You can see here that my banana data is being sent from my phone, and it can be for like making bread, for making smoothies. Maybe it's a bit weird to make pizza, but if you can put pineapple in pizza, why not? And then for a fruit basket and so on. Pool-based privacy would allow all of these because it's my phone and my data. So it's me and it's my data. And if we just had ACLs on can my phone actually access this data, since I am the user who's trying to access the data and send it the request, it would all be okay. Purpose limitation, however, requires us to build a new framework that only allows some requests to access my banana data on my phone. Now let's look at the scale and diversity. Ensuring that the safeguards work consistently across various languages, runtimes, and the types of workloads, and at meta scale is really not easy. Just to put some perspective on the scale, we have 3 billion plus daily active users. That's a massive request volume flowing through our servers. We have millions of assets And I will use this terminology asset quite a bit. We use asset for any chunk of data or even code or code blocks. So think of it as like maybe as granular as a function or an entire request or a microservice if we're talking about code. And for data, it could be a MySQL table, it could be a cache, it could be a row in a table, so on and so forth. But the important thing to understand here is that we have a huge number of assets, so the scale is really, really high. And we have a multitude of data systems. We have systems that are processing web requests. We have async batch processing frameworks. We have like machine learning training models. Now we have generative AI, so on and so forth. So we have a lot of very, very different kinds of systems and a lot of different kinds of like workloads and machines, which have different compute capacities, memory, and so on. We also serve or have a lot of different languages. So name it, and we probably have something or some service built on that language. So you can think about like Hack in PHP, which is very common. We have Python, we have C++, Rust, JavaScript, Java, all of those things. So there's a lot of complexity associated with handling all of them and all of these systems. And another thing to remember here is that at Meta, we have continuous push. So a lot of other places have like weekly or daily pushes, in which case we accumulate all the change sets together and then run a bunch of like tests and like we dog food for a bit before we actually push it out into production. At Meta, we do a continuous push. So once a person's change set actually merges with the main branch, there's a whole suite of automated tests. And if all of those checks pass, that change set is going up. And it's not really feasible at our scale to stop every push and check if it's not doing anything wrong with data. And at this scale, it's really not possible to do that as well. Now to look at the another way to look at the scale is the number of employees and teams that we actually have. We have more than 50,000 employees, and it's not really possible for everyone to be a privacy expert. A single request spans many, many, many teams. So if we look at this example here, there is a banana smoothie request. The initial portion over here is owned by the Banana UX team. This then sends some data and talks to a few DBs and does a few logs. This might be owned by the fruit storage team. And then the data goes to the data warehouse. And then data from the data warehouse is used by the smoothie ranking team, which builds models and classifiers and then trains on this data. And then finally, all of this is used in a smoothie service as well, which is owned by a different team, which is finally used to serve a part of the banana smoothie request. So we can see that a single request actually touches so many different teams. And some of these teams could be like hundreds or like even bigger in size. So we have to coordinate across all of these teams. Another thing is that when we're thinking of privacy requirements, the teams that are actually enforcing them are not any of these teams that I even mentioned in this example. So a lot of our orgs or departments have a specified privacy team that makes sure that all the requirements are being adhered to. And these teams are not the teams that have good product expertise. And so they need tools to help them understand how data is actually flowing through the system. They're not the teams that actually built the banana smoothie request. And so they have to understand how is the data flowing, who is using them, why is it okay, and all of these things. And data producers and consumers are often different entities as well. So it's not like the requirement or the privacy team can just go and sit down with one team and say like, hey, can you tell me how the data is being used? How are you collecting it? It's all different teams that are working on these. So there's no single point of contact as well. Finally, let's look at the granularity. So data and scope may be present at different levels of granularity, and this makes precise tracking and enforcement challenging as well. So for example, a given table may be entirely banana data. So you can see that in the first table, this table is just about bananas. Every row and column has some sort of information about bananas. Whereas you could have, think of an ice cream or sundae table, where there's just one column in that entire table that has information about bananas. And then you can think of a table that has mixed data, in which cases some rows are about bananas. So this could be a fruit database. Some rows have a banana information, other rows are about apples or other fruits. And then, of course, there's the degenerate case of just one cell has banana-related information. So all of this makes it really, really hard to track first, where is the banana information? And then we have to understand where is the banana information going from here as well. And this granularity is not a problem just for our data assets. It's also a problem for our code assets. For example, if you think of multi-tenant services or frameworks that take in different types of data through a common choke point. So we have two separate examples here. Let's look at the one on the left first. Here, banana is not being used for bread purposes. So the store bread operation is not going to have access to any banana data, but it does go through store food. And store food, depending on the context, sometimes has access to banana data, but if it's going through the store bread stack, then it does not have access to any banana data. So this function sometimes has banana data and sometimes doesn't. So you can see that here also the granularity matters. Another way to look at it is that a part of a given request or a service deals with banana information. So in the make breakfast example, you see that the part of the request that's making omelets or eggs doesn't really have access to banana information. But on the left side, I can see that there's access to banana information and we're trying to make a smoothie. I see a couple of hands. How do we do questions here?
One here, I think. I
was raising hand.
Oh, you were raising hand too. Okay, you want to go first?
No, it was for you.
Okay, thank you. So I was wondering if at some point, because you're talking about granularity, one issue sometimes is misalignment. So you can go very, very fine in terms of granularity, but potentially not be aligned with what people care about. So imagine that, for instance, people don't care about whether or not banana goes into bread, but they really don't want banana peel to go into bread. And that's, the level of concern that they have. Are you going to be discussing that a little bit and how you come up with
Yes. I will touch about that. I don't go into detail, but I can talk about that at the end. But I do have a few examples where we talk about like banana data. We don't want to say that banana data absolutely shouldn't go anywhere. It's banana data in its most sensitive form shouldn't go anywhere. There are ways to desensitize it. And obviously I have like a example here, but in general, what we think about is that if sensitive data is sufficiently anonymized or the sensitive parts have been stripped out, or it has been sufficiently aggregated, there are cases in which that data does become acceptable to use. So it depends on how the privacy requirement is phrased and at what point do we feel that the banana data has been sufficiently desensitized that it's okay for it to go to other parts of the system as well.
I guess my question had to do with, and I don't know how far along you are with that, but to what extent are you working on aligning those constraints that you're able to specify with the way people think and the issues that they're concerned about, right? So you can come up with all sorts of different settings. You could potentially, flood people with settings, but they may not necessarily be things they understand or things they're concerned about. And so that's the question. And feel free to leave that for later if you would like to. I don't mean
Yeah. So we can deep dive a bit into how we're setting like the requirements itself. But maybe I'll go through the talk on more like how we're building the infrastructure, and we can deep dive a bit into how we do approach some of these questions. But they're very valid questions. It's very top of mind, especially for people on our teams who are working and building on some of the work over here.
Great, thank you.
Cool. So with that, let's get into our approach. I'll start with a high level of how we're doing this, and then we can go into more specifics as we progress through the slides. Okay, so our approach, previously we described some of the challenges we have, and now we're going to talk about how do we actually solve it. So here I'm going to talk about the workflow from the perspective of a requirement owner. So like I said, this is most likely a privacy team embedded in each of these orgs or departments. The requirement owner is responsible for the technical implementation of a given requirement. This is typically a different person like I said, then the code owners and the assets. The overall approach for purpose enablement is as follows. First, we want to discover the assets. So essentially, we want to go and find out where are all the places that we even have banana data. So step one is find the banana. The next step is we want to now discover the data flows. So where does the banana go in our systems? The third one is to remediate the data flow violations. So we're going to look at everything as a data flow, and some of these data flows are going to be fine and compliant with our privacy requirements, and some of them may not be. So the step 3 is all about checking the uses of banana and deciding whether this is okay or not based on our privacy requirement. And accordingly, we will have to discuss some of the remediation strategies. Finally, once we're in a state where we think everything looks good, we want to start locking things down and get us to a state where we don't have any future banana misuse. Lastly, we want to make sure that this is a continuous process and it's not a one-time check because at our scale, it's not going to work if we do a one-time audit and check and make sure that everything looks good. So we want to make sure that banana use protections continue to work. So it may sound pretty straightforward, and really the thinking behind this is not that complicated, but it's a lot of work. And let's look at each of these steps. So the first step here to discover is to discover the asset. So we look at all of our data stores, and then we have to decide, does it have banana? Yes or no? And finding the banana can involve a lot of different techniques. In some cases, it might be very straightforward. So is the table named as banana? Or sometimes the name itself is like super informative. And that is the most straightforward way. But for a lot of cases, what we do instead is that we go to some of the common choke points that we know are collecting this kinds of data, and we start annotating them or marking them. And we have specialized lineage tracking and tracing tools that we use based on runtime logs to identify where is the data going and where is it being stored. So in this talk, I'm not actually going into all our lineage work. This is also a big portion of what we call as privacy-aware infrastructure. Here, we're going to be talking more on the purpose limitation aspects of it. So there might be other examples as well where we write classifiers and detectors to actually look at runtime data and see that if it matches certain conditions, can we look and scan and mark them as, oh, this contains banana data. Once we find the banana candidates, we then review and annotate them based on scoping rules. A lot of this is automated, all of this process that I mentioned, but then there are some cases, and we try to minimize the number of cases that actually require a human review, but it does come down to it for certain complex cases where the classifiers are not able to do it with high confidence, where we try to minimize the number of set and then have a human go and mark it as, yes, it contains banana data or not. Yes?
I assume, and sorry to ask these questions, but I assume that for the time being, we're not really concerned about foundation models or agentic AI here. We're talking about...
Yes, yeah, that's right.
Just wanted to clarify.
Okay, so then step 2, now that we have an initial understanding of the seed assets or where banana data is starting to originate, we can now start looking at the data flows. So once we have this bunch of assets, the first set of seed assets, we have 3 types of scenarios. So since we're talking about data flow, you'll notice me mention source and sink a lot. So every data flow is going to have a source and sink. And in our worldview or how we've built the privacy-aware infrastructure, we look at everything as data flows, which has a source and a sink. So if you're reading data from, say, a SQL table, then the source is the SQL table and the sink is your code. And if you're writing data, your source is the code and the sink is the table. So on and so forth. And source and sink pairs don't have to just be code and a table. You can also pass data via RPC. You can pass data from one function to another. So everything is considered as a data flow. And this is how we've modeled our systems. So we have 3 types of scenarios now that we have the source and sink with data flows. The source has not been annotated as banana. Yes?
So the reason why this is for review is because you want to manually consider whether potentially also annotate now that sink as banana. Is that that the idea? So like, okay, now we discovered that banana is flowing into this sink, and perhaps we need to start annotating that sink also as banana, or
Exactly. Yes. You got it. You beat me to the chase.
okay,
So no, that's exactly fine. I'm glad that everyone is able to follow along. So we've annotated a bunch of data assets over here, and we have three types of scenario, right? Source data that has not been a source which has not been annotated has data flowing from the source to the sink. This is allowed because we're saying that there's data. We don't know what kind of data it is, but it's going into a sink that has been marked as banana. It doesn't seem to be doing anything against our privacy requirement. The second case is the source has been marked as banana. The sink has also been marked as banana, and this is also okay. Well, it looks like both of these cases, the source and the sink, have been approved to process banana data. So this is also a good case, and we don't really have any problems. Now, the third category is where it gets interesting. We have data flowing where the source has been marked as banana, but the sink has not been marked as banana. So in this case, we actually need to review this. And this is what we do. This is our step 3, where we're actually remediating data flow violations. So let's look at this option in a bit more detail. We have 3 options here. The first one is the sink asset is allowed to use banana. So it's just that because we're getting started with the problem here, it's not that the sink shouldn't be using banana data. It's completely fine. So what we would do in this case is just go and mark the sink asset as, yes, you are also allowed to use banana data and stamp it with banana. That's the first way to remediate. The second one is, hey, so yes, data is flowing from the source to the sink. While we do see that, we're saying that actual banana is not being used in its sensitive form. In this case, we can mark the flow that it is okay to drop the banana annotation. We refer to this as reclassification. So in this case, what we're saying is, yes, data is flowing from a source that has been marked as banana, but we think that the sink is not really using banana data in its sensitive form, and it's been sufficiently desensitized. So we go and we do a special marker over here saying that, hey, this flow is okay and has been reclassified. The third one, of course, is the sink is maybe making bread. And we just mentioned that our privacy requirement says that banana data cannot be used for bread making purposes. And so in this case, the data flow needs to be broken or blocked. So this is kind of how the initial process looks for the team. A lot of this is automated. So there's a bunch of like data flows that has to be reviewed. In many cases, again, we can use a lot of automation to figure out if the sink should be also marked as banana or not. And we try to reduce the number of assets that need human review. And then we go to some of those and decide whether it's okay to drop it. Dropping the data flow is a little bit more invasive. And so is reclassification, because now you have to add specific verifiers and validators to make sure that certain levels of guarantees are maintained before we actually say it's okay for this data in this form to flow into the sink. So steps 2 and 3 of finding banana data flows and fixing them is repeated recursively until no new data flows is found. And I say recursively because if you noticed over here, reclassified, as in the middle one over here, and blocking the flow actually don't create new data flows. But the first one, where we actually go ahead and say, hey, the sink should also be marked as banana, creates more data flows, because the asset over here that's sitting, that's acting as a sink, could now be acting as a data source or a source for a bunch of other data flows. So now we have a lot more flows that we need to review and decide whether the sinks in those data flows need to be marked as banana or reclassified or completely blocked. So this happens recursively until we reach a state where there are no new data flows that are found. So in step 4, we're in a state where everything looks good. Banana data is only going to places that it should be going. And in any other places, we have sufficiently desensitized the data. So we prevent new banana misuse by locking things down. We've built a variety of techniques that span checks at code changes when you're making them, or at diff time when you're putting it up for review, all the way to even runtime program execution. that stop the bad data flow from happening. Yes?
Excuse me, I've had a couple of questions. So first, when you say banana data, do you mean a certain type of sensitive information, or is it a certain user, or is it just like anything, or?
It's usually, it's a great question. And I think specifics would have been like easier, but like I'm not allowed to discuss that, which is why it's a bunch of like toy examples like banana data. But usually it's not user data. It's a specific kind of information. So we usually, I think a good example would be like if you're looking at a user and you're a hospital, maybe you have healthcare information, right? It's not just about a specific user. A user's health information should not be used for something else without the user's consent. So those are the kinds of data that we're talking about. We have a lot of different data requirements. And like I said, if you go and Google about purpose limitation and GDPR, you'll find a lot of very valuable examples of what purpose limitation actually adheres to. Did that help?
Yes, and then I also wanted to ask, in the previous slide, you said that for whenever it's removed or blocked, is there a protocol to where you decide whether or not to remove that data or to block it, or does it just depend on the discretion of the privacy engineer at the time?
So these are pretty strict, right? So if we can either go and annotate the sync also as banana. If not, if we're deciding to reclassify, we have a bunch of very a high bar on the set of validators that we write, and then we get this once the entire privacy requirement is in a state where we feel that it's ready. We actually have internal audit teams that go and they try to poke holes and hold a really high bar. So in some cases, they'll come back and they'll say like, hey, I know you're saying that it's okay to use the banana data because it's been desensitized, but we want you to make sure that you've implemented some automated checks and show us how you're doing it in a way that is good enough. So now for the third case, which is, I know what you were asking about, how do we go remove the flow? I think if we don't see that it's okay to desensitize it, we're usually just walking up to the team that is actually consuming this, and we're telling them, hey, we're going to like stop giving you this data. Yes, it may affect how your product operates today, but we have to get this done. And it's like I said, privacy is a pretty big priority. So we usually don't have much pushback if we're not able to. If we're told that you cannot use this particular data. Now, and I think we've had this discussion a bit before on like how do we decide what is okay and what is not okay, what is an acceptable use, and that comes from how the requirement itself is phrased. And at least for the privacy teams, they work very closely with our policy and legal teams that advise us on like, hey, these are the kinds of cases where it's okay to use it. If you have services that is, and I mentioned previously as well, right? Like if you're making a fruit basket, then maybe it is okay to use banana data, but you have to get a prior approval and it has to be documented. And there's process where you have to say that it's okay to start using banana data for fruit making purposes. But if you're using it for bread making purposes and you're not able to get that approval, it has to be removed.
So I raised my hand, so I'll ask a quick question. So I think what's potentially slightly confusing is to refer to this data as a type of data like banana data. It seems to me that there are potentially two different concepts here that are being presented in the same manner. One is the type of data per se. For instance, I would think of location data, right? I would think of financial data, health data, etc., as being a type of data. And then a separate concept is the purpose. I'm assuming that when you're talking about this right now, you really mean purpose. For instance, perhaps the banana concept means that the data was collected with approval to use it for, sale under CCPA. And the sync might be, a particular advertising network. And right, so that's what we're talking about. So we're not really talking about data types. we're talking about purpose of data. Is that correct?
Yes, that's right. So to be, and I'll get to it as to, I can see where the confusion is coming from. So we started with a lot of overly generalized, like I think 4 years ago when we started with a very, a rich representation of how we did the purpose and the policy definition. And then it became much harder for developers across the company to understand it. So for example, you can think of it as like the purpose here is that it can be used for smoothie making purposes, right? And when we're talking about annotating the source and sink as banana, what like you just mentioned is that I'm not saying that the sink is a banana or that the sink contains banana. What I'm saying is that the sink is allowed to make smoothie data and is allowed to process this kind of banana information. And so usually it is to your example of like say financial institutions, the sink is annotated as something that is allowed to process financial data. The sink is not annotated as, oh, this contains credit card information. So to your example, the data itself is like, let's say your credit card information. The purpose or the annotations that we add either to the data assets or code assets is that is allowed to do financial operations. So your credit card that is stored in a maybe credit card DB also has can be used for financial purposes. Your code assets also say can be used for financial purposes. And so in those cases, we're saying these are approved flows. And then as we find new flows that pop up in the system, we're like, oh, data is actually flowing from this code asset that has been marked as can do financial or can handle like financial data. It's not going to a database or a log or something else, which has not been marked. So in this case, we can either go and say like, yes, go mark this new system, which is acting as a sink, also as yes, can process financial data, rather than you're not going and marking the sink as, hey, you are a credit card. You're saying you can process financial data. So yes, there is a distinction between what is the data itself and what are the purposes in which you can process the data. We simplified it for the purposes of this example because like I said, we started with a very, very rich definition in our policy set, and it was extremely confusing to developers as we started along because they mostly don't have a good understanding of what is like like I said, we have 50,000 engineers, and most people don't understand like what is purpose limitation. Why is there this annotation on my database, or like, wait, why is my endpoint being annotated as I don't know, like imagine a team that has no idea what like a financial transaction or like financial purpose is, and their code is now being annotated with something. It gets super confusing. So we found that it's much easier to phrase it more as like, oh, can contain banana data rather than is used for smoothie making purposes, so if that helps.
Yeah, no, these annotations are allowed purposes, right? And so
yes,
if at some
that's
point
right.
a user were to opt out of something, then you might potentially, you may still be able to collect the same data, but that data may end up in a different sink or maybe only a subset of the sinks that was allowed to flow to before.
Yes, that's right. Exactly. So when I say you're like stamping or annotating it with banana, what we're actually saying is that you are allowed to process banana. And that is kind of how we have changed it from like, instead of the purpose has been phrased as, in terms of technical limitations or annotations as can use banana data, if that helps.
Yeah, it does. Thank you.
Do we have time for another question?
I think we do.
Yeah.
Okay. Yeah. So, Amrita, you mentioned that there are ways that we can remediate data flow violations, and I think I'm assuming that it must take time between the data flow violations occur until it actually gets remediated. And since we're discussing privacy-aware infrastructure, I'm wondering, as a software engineer on the team, like what are some of the performance engineering considerations that you have to put in mind, and what is optimizing for latency and throughput for remediations? What does that look like?
I will get into some of the performance aspects a bit later. Very, 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 very pertinent question, because We are phrasing a lot of our purpose limitation requirements as we're going to check every single data flow. And I did mention our scale, and later in my slide, I mentioned this as well. So today, actually, I just checked this on, I think, last week, as I was making the slide deck on how many checks we do in a day. And I think it's like, there were so many zeros that I had to Google what the exact number was. And I think it's like 5 quintillion checks per day for data flows. So that is the level at which we're doing, and this is just for the data flow check. There's a lot of complexity that goes into this library because we're not just checking data flow. There are even things like, oh, if you mark something as being in this policy, you have to instantiate it, and there's a lot of complexity that comes. But I'll talk through some of those things later, because if we build something that is not performant, I mean, if it's prohibitively expensive, we might as well just like pack up our bags and say this is not going to work. I don't know if I already mentioned this, but we started a bunch of this work in 2020. And last year is the first time we felt that, and we've been applying it to a lot of requirements, learning from each experience, simplifying things, both from the developer experience and like optimizing performance. And we're finally at a point where we can actually enforce all our privacy requirements at scale, with a reasonable turnaround. Like once a new privacy requirement comes in, we're now finally in the state where it can take, yes, it is still going to take the privacy team a couple of months to go and identify all of these places and lock everything down. But it is doable within a couple of months time frame. And once we have that, we are able to keep the enforcements on so that it's, continuously being checked forever going forward. And that means that we have all of these restrictions running all the time at this scale. So I will get to all of that in a bit. And you'll see that there's a lot more complexity over here as well.
Great, thank you.
Cool. Yeah, so once we have everything logged down, like I said, we want to continuously monitor and make sure that new banana sources are discovered and remediated if they happen. And we also want to make sure that the invariants around reclassification are maintained, and any additional out-of-band checks pass. So for example, we also have like monitoring tricks like poison pill tests, where we actively inject, say, test bananas, and we add detectors to check if any banana-related information pops up in the bread factory. So all these steps together ensure that we can use bananas as intended. With that, I'm going to go into a little bit more of how we're managing the data flows and walk through some of the examples. Cool. So this, the first part where we do the data asset discovery, like I said, is a different portion of our privacy-aware infrastructure, which is about data lineage, data discovery. We have a separate set of tools and systems that allow us to do step one. But then the 3 steps in between, which is about discovering the data flows, remediating the violations, and preventing new violations, are grouped together. And at Meta, we developed a special technology for this. Again, to refresh, we mentioned earlier that purpose limitation is quite different from the who-based problems. And we had to develop a new approach over here. And this approach is what we call as policy zones. So what is policy zones? At the heart of policy zones, and I think I've been mentioning this across the talk here as well, we look at everything as a data flow. So whether it's a read or a write from a code block to a data store, or whether it's data moving across code boundaries, and this could be RPC, it could be within the same process as well. Everything is a data flow. And it's actually surprisingly not based on a super new concept. It's based on information flow control theory. And for those of you who are interested, I think there are papers that go all the way back to maybe even the 1970s or 80s on this. And there's like some really good published work over here for us to understand what information flow control theory talks about. So at a high level, this is a security concept that focuses on managing how information is allowed to move within the system, ensuring that sensitive data does not leak to unauthorized areas by defining strict rules regarding data transfer between different security levels. This essentially prevents information from flowing from a higher security level to a lower one without proper authorization or mitigation strategies. And this proper authorization mitigation strategies is the reclassification pieces. And then you'll also find in this work that there are some constraints on how the policies need to be developed in order to be able to use information flow control theory. As a quick summary, I'll just tell you that the policies need to form a lattice, which is a mathematical concept, and otherwise you cannot ensure that we are sticking to this high bar that information only always flows from a lower restrictive, does not flow from a high security region to a low security region. So we can think of different types of policies. So before we start actually doing any of these steps of like, hey, let's find the data flows, let's figure out what annotations to add, we first have to define our policy lattice. And so we have, in some cases, we have very complex policies where you have multiple different policy nodes in your lattice. And then a lattice needs to have a top and a bottom, and there always has to be a clear comparison between which one is more restrictive or less restrictive. So in this example, and if you also look at a bunch of like published work on information flow control, a common example is FBI and classification levels. So in this example, you can see that, let's say that a file or a piece of document has been marked as secret, and then there's an agent, and he has top secret clearance, then yes, the secret file can flow into the hands of an agent who's only allowed to see top secret information. But the vice versa is not true. Let's say there's an agent who only has a confidential clearance. He or a file that has been marked as secret cannot flow into his hands. So this is an example of how the policy lattice is structured. Like I mentioned a bit earlier, we did have a lot of very rich representations when we initially started out. We had a very rich purpose taxonomy, a very complicated purpose graph, and we mixed all of these together. But what we found out was that in our V0 that we launched back in 2020, developers found that very, very confusing. And so instead, we moved into for the most part, not all requirements. Even today, we do have requirements that have, like, let's say 5 to 10 nodes. And then we have to define the strict ordering of, or the lattice structure of which policy can flow to which policy and whatnot. But for a lot of very common cases, like I think we discussed like the financial information, we just say, can this asset, whether it's a code asset or a data asset, can it access financial data? So it's like off or on, and off can flow to on. So that's the simplest version of the policy we have. And for cases that truly do require a slightly more complex setup, we have those kinds of support as well.
So these are very flat lattices at the end.
That's the example I gave you, but we do have examples where it's not flat. So you can, there are more, like we call those as like graph policies, but they have like I said, we have policies which have like maybe 5 to 6 nodes. Yeah, layers. And yeah, we try, like I said, in our V0, we had a very, very, very rich system that was super confusing. So we instead tried to look at it at per requirement. And per requirement, if possible, we encourage most people to gravitate towards the on-off system, which is unsurprisingly very, very easy for developers to grok. For cases where that just doesn't cut it, we do allow defining policy definitions that are a little bit more involved. So you can think of it as like, even like if you have something like, not fruit information at the top of the lattice, and then you can say not fruit information can flow to banana, not fruit information can flow to apple. And in this example, apple cannot flow to banana, or banana cannot flow to apple. And then you can have a all fruit policy in the lattice, and both apple and banana can flow to the all fruit policy, which is an example of a case that can actually process both kinds of information.
Right.
And then another one, and I remember somebody already asked about the scale. We have the core construct that we have over here is that data can flow. And we supply a from policy and a to policy. And this check accounts for like 5 quintillion checks per day. which comes down to like 58 trillion checks per second. And to add a little bit more context, I only checked this for like one of our it's one of our biggest services, but that's the only one I checked it for. So this doesn't even showcase the scale across all of Meta. It's for one of our big monolith services.
Can you place some kind of a percentage in terms of the overhead that this has on, the overall processing requirements at Meta? I mean,
yes. So yeah. So our initial, I remember in 2021, I put out this like very, very scary projection where we were actually using it only for, we had our pilot requirement that we needed to comply by end of the year. And so we started doing it. It was very expensive, but at that point we were like, hey, this is the only way we can comprehensively enforce it. And so we had, for that requirement, our leadership gave us like, the equivalent of a blank check, go like do whatever you need to do to make sure that we are doing the right thing. And that was for relatively, I shouldn't say small. It was like one feature that we support. It's a very popular feature, but it was not all of Meta. And so we were like, hey, as we go forward, there's going to be, some sorts of data that actually travel, across every single system that we touch. And in those cases, if we had to do this, what would it look like? I did back of the math envelope based on like current costs and projections. And I said that we would need something close to the order of the entire Instagram web server fleet, whatever we have, we would need like 1.2 times the number of machines that we have serving the entire web fleet. That was where we were in 2021. And so we were like, hey, okay, it worked for this feature. And I don't think we're going to be able to do it for other features if this is how expensive it is. So this led to a lot of like follow-up work on like seriously optimizing a lot of these things. And another important thing to note over here is that I mentioned that we have purpose limitation happening across different languages. So we built we have a policy zones library, the core library functionality that we built. We first started it out in Instagram with Python and in our big monolith services in Hack, which is close to PHP. And so we were like, hey, it's not going to work if we're this expensive. So what we started doing is that we gave a promise that we'll bring it up to a regression that is manageable. And in the meantime, all the requirements that needed to start onboarding, we said, hey, let's start doing it with sampled checks. And yes, sample checks is not perfect, but we don't want to block people. And in the meantime, we started working on performance. Today, I think our latest checks, is that it causes somewhere between a 1 to 3% regression on our web tier fleets. So a 1 to 3% regression essentially means that we, let's say you have 100 machines that are backing our web tier fleets, then we need roughly somewhere between 1 to 3 machines extra just to do privacy checks.
It sounds like it's probably in the order of $1 billion or more, nevertheless. And you don't have to say yes or no, but it sounds like it's pretty sizable.
It is sizable. It is sizable.
Thank you.
Okay, so yeah, so let's look at some of the examples over here. So we have a banana request. It's calling a banana DB, and then it's doing some logs. And then we can see that this is a case where you have a source, which is the banana DB, and the sink is the banana request, and this is a data flow violation. If you want to actually look at how this looks, like I mentioned, we first built the core policy zones library. And then the policy zones library is now integrated with every single, both like code processing framework and database storage or logs that we have. So for the developer, this looks, or the privacy team that is actually enforcing this requirement, this is how the experience would look like. They just go, they open up the schema. In this case, there's a banana schema. Maybe this is backed by a SQL table, and this schema is just for the ORM or object representational model. You see a bunch of attributes, and just like you're defining the schema here, you can just go and say policy, and here the policy would be, and again, not to be confusing, I know it says banana. It doesn't mean that it's banana. It means that it can we're saying the purpose of like can process banana data. And that's what we're marking it as. So coming back to the example, we have banana DB. We have a data flow violation. In this case, banana request should have access. So we remediate just by annotating it as banana. In this case, again, the annotation looks really, really simple. In Instagram, we use Django. And with Django, you know that you have endpoints are defined as views. For those of you who are familiar with it, so this is how the construct would look. The privacy team would just go and stamp this decorator saying policy zone view, and the policy name would be, in this case, the banana. Now, again, we have a new violation that has been detected, which is that a banana request is the source, and then we see a sync to log B. Turns out that log B is allowed to process banana data because it's specifically for the same purpose that it was collected for. Let's say it's for smoothie debugging purposes. And so we think it is within scope. And we just go ahead by remediating it by also marking it with a policy. So I'm showing you a bunch of these annotations, and they're not super complicated, but the work that went to enable them is very complicated. Essentially, to the privacy engineer on each of these teams, it looks like all they have to do is like, oh, open up the schema and just say, oh, I'm marking the policy. But somebody has to actually read the policy for every data flow that is happening from each of these assets and make sure that they're being validated over here as well. Go for it.
So what's part of reducing that overhead, coming up with the right taxonomy of concepts, sort of looking really at the data, the mix of requests that you're getting, and coming up with concepts that reduce the overhead? Was that the key?
Actually, I would say no. The taxonomy simplification was more for like the developer experience and to make it less confusing. The optimizations we've done in a bunch of like different ways. And I know I mentioned a bunch of granularity a lot, but it's much easier. For example, if we say that an entire table is banana data, by the way, even things like constructing the policy object is actually very expensive. I only mentioned the can flow operation because that is the one that happens at the highest throughput or like highest frequency. But a lot of other costly operations are like instantiating the policy object. So what went into the performance optimization was essentially caching, or like where possible, go to the highest granularity of representation. And that actually helps reduce a bunch of the cost by, I would say there's layers of caching on how we do it without compromising on correctness at all.
It sounds like you've said actually yes, right, I know, because it sounds like when you're talking about coming up with a higher level concept, that's going to do the trick. You effectively sort of modifying the taxonomy, or at least ensuring that you're referring to, as high a possible element in your taxonomy to simplify the processing.
Yes. One other important requirement that we had is that, so today we only looked at banana, right? But it's probably more likely that maybe not for a log, but for the cases of, let's say, a request, right? Many requests are going to touch many, many different systems. And so they should be allowed to process a lot of different kinds of information. And so one of the promises that we made is that even if you're going to add like a bunch, like today it just says banana, but let's say you add like a list of policies or a list of like accepted purposes, we still don't add any additional cost. Once you've created a policy, once you've created a zone, it's even if you slap 100 more policies onto the same asset, we will make sure that there is no more extra cost being added as well.
So these zones make a big difference also. A related question is, so how do you ensure, you're doing, these quintillion, or these trillions of dollars, these trillions of checks per second, right? And so presumably these checks are not a waste of time. Occasionally they come back and they say there's a problem. And so how is this being reflected at the level of the end user? I mean, how do you ensure that, this is all gracefully degrading and the user doesn't really say, hey, what's going on here with Instagram? This is going crazy. I mean, every request I submit, there's a problem.
Yeah, that is a fantastic question. Again, when we started with our first requirement, so policy zones have two modes, right? So when you're still in the data flow discovery and remediation phase, it's in a log only mode. So the end user is not having any interruption to service, as we're still figuring out and slapping these annotations and so on. When we come to step 4, which is that, hey, prevention, we've annotated everything and we think everything looks great. We're at a point where we want to turn on enforcement, which means any new bad flow will actually cause a breakage, right? So as much as possible, we've tried to shift left in terms of where the breakage is caught. So we've had like slightly different implementations across different languages. For example, in C++, we've tried to use like template magic to build violations that will break at compile time. So that's for, again, these can be done for the higher granularity ones. They become sort of not really possible for the cell level and row level granularities, because that at runtime you have to figure out. You don't know when you're accessing the table itself. If you're accessing the table and you always know that it's the same policy on the table because the entire table has like a specific kind of data, you can do some of these earlier checks which fail at compile time. But if you're saying, oh, some rows can have banana information, some rows don't, then it depends on that particular code flow. And we have to decide, should I instantiate a banana policy? And you can only fail at runtime. Right. So those are more complex, and those do cause runtime violations and will break service in production. So to prevent that, we have, and actually that is a point that I will get to, that we are still working on better detection and earlier catching of some of these flows. So for those kinds of things, we are trying to figure out if we can look at traffic replay in certain cases to say that, hey, you just mark this asset as sometimes containing banana information at a row level granularity. And we've seen that rows from this table have been accessed in an asset and you are fully enforced. This is probably going to cause a violation, right? Because we have some of this traffic access patterns, and we can predict some of these and throw some of these alerts even when you're just putting up the code for review, and even before it gets into the push string. Now, for lower volume breakages that, because these sample like request patterns logs are also, as I mentioned, sampled, so they are going to miss things that don't happen very frequently. And for those cases, we're taking the stance that it's more important to make sure that users' data is handled the right way than not causing an occasional breakage. So we're going to let some of those things actually fail in production, and we have alerts and monitoring to catch when any of these things happen, and we can remediate as quickly as possible. So usually remediations happen in the order of like a few hours. Occasionally, I've seen it go down to 1 or 2 days, but those are really rare and taken very, very seriously if something had to happen in that scale.
I think there was one more question, and then we'll let you finish because we've been asking a lot of questions.
Yeah.
Go ahead.
Yeah. Thank you for this. I had the question about policy creation. You mentioned that the privacy engineers need not know. One second. The privacy engineers need not know about the policies that are there, but they can just check the annotations and figure out if that's the correct one. So who actually, who has the burden of creating those policy and maintaining it for each of these data flows?
Good question. So maybe there's one thing that I could have clarified in the beginning. There's, I would call it as the privacy infra engineers, which is where I would put myself in. My job is to build all of these like tools and infrastructure to enable privacy teams. Now there's teams that are, like I said, embedded into each of our product orgs that are focused on privacy. These teams, so I'm not the ones who's actually directly enforcing that banana data is not used for bread making purposes. Me and my teammates have just built this infrastructure. The privacy teams, which are embedded in each of these product orgs, sit down with the lawyers, and then they decide how to distill the requirement into a policy, right? So they sometimes, if needed, and we're trying to also, and that's where the taxonomy simplification really, really helped, is in the beginning, for every new privacy requirement that was being added, the privacy engineers on those product teams go and sit with the the policy folks, and then they come back and then they sit with us and they're like, hey, like, how do I now convert this English requirement of I don't know, like banana will not be used for bread into a policy in this lattice, and how do I like create a specific policy, right? And that was a pretty big effort, because now we as the infra team has to understand the requirement and help and walk them through the policy creation in a way that makes sense, which is where going to this highly, for like majority of the cases, going to this on-off helped us scale ourselves a bit, where the privacy infra folks don't have to sit with the privacy engineers embedded in these product teams. And they just have to talk to the legal and policy teams, and they can draft their own policies.
Thank you.
We don't have much time, and I have quite a bit of content to go through.
This is super interesting. We're not going to interrupt you until you're done.
No, I was just going to say, yeah, maybe I'll do all the other questions at the end.
Yes.
Okay, I'll try to go a bit faster as well. So this part, I think we're good. We talked through this. Okay, now we're in a state where all violations are resolved, and this is when we would go ahead and like turn on enforcement, go from logging mode to enforced mode. And I also touched through some of the implications of what this means for outages and breakages, because of some of the questions you folks asked. So one kind of terminology that we used over here is that now banana request is running in a banana zone, because we mark the request as running in a banana zone. Okay, so once again we're in prod or production, sorry, if somebody tries to do a log to this new log, which is actually used for bread making, this would throw an exception and we would break. Sorry, I'm just powering through it because we kind of discussed it over here. Okay, so now let's look at a slightly more granular example with a code over here. So in this case, the banana operation may be a very small portion of the entire request. So you can see that there's a breakfast request. I'm sorry. And the make banana smoothie function is just one part of the entire request. There's another data flow violation to remediate between make banana and make banana smoothie. Since make banana and make banana smoothie seem like it's they should be accessing banana data, we would go ahead and say that it's okay to go up to the next frame on the stack and mark that as banana. But now, and this is where it starts getting interesting, we have a different data flow violation to remediate. The data flow from make banana smoothie to breakfast request. And this is a good example of where we do use reclassification. So in this example, you can assume that, hey, I think we've sufficiently desensitized the banana data. And maybe the requirement here is that, hey, we've added banana, we've added maybe some spinach, we've added sugar and milk, and we've blended everything together. So it's no longer clearly recognizable as banana data. And so in this case, we would say that it's okay to reclassify. And so we're back to a state where all violations have been resolved. So to do this at scale, though, we're not actually labeling every function in the code base. It would be insane if we went and we said, like, hey, let's look at the breakfast request, mark it as something. Let's look at make banana smoothie, mark it as yes, can process banana data. Make banana, yes, can process banana data, and so on and so forth. Like, you can imagine that the number of functions that we would have to annotate would just virally explode. So what we do here is that we're just claiming that make banana smoothie is running in a banana zone, as are all functions below it that it calls. So what we're doing here is we're propagating the zone, the current zone, through the stack implicitly. So now this adds another layer of complexity. And this was an intentional design choice. We could have gone to the explicit choice. Essentially what that would say is that each function accepts its like zone or context as a parameter, and then it has to explicitly pass it down. This has several pitfalls. One, imagine if one of the callers in the call stack don't correctly pass it down. If one of the callers create their own thing and they modify it and then they pass down something else. So you kind of get into all these problems of like, you have to trust that the chain is not being broken and it's correctly being passed. So there is one issue with trust and correctness. But then there's also a second issue of now you would have to code mod every single function in our code base over here. All of them now need to accept this zone context, and that would also not be scalable. So for this reason, we built the ability to propagate the zone context implicitly. And now I can enable enforcement for the banana, make banana smoothie by creating a banana zone, just like I did for the request earlier, and prevent future data flow violations. So this is how it would look. You can see that the annotation over here is now on the async make banana smoothie function. But the annotation actually looks pretty similar to the one where we marked the request itself to be in a banana zone. But it actually adds, there's a lot of nuance over here, and I'll talk about it in a bit. And before we get into that, let's look at some of the multi-tenant examples that we touched on as well. So you have breakfast requests, and let's say it's calling make banana smoothie and make toast, and both of them call a make food function over here. And make food, depending on the context, is sometimes dealing with banana data, or sometimes it's dealing with bread data. Similarly, FoodDB, some of the rows have banana information, some of the rows have bread information. So in this case, again, what we do is that the part where we have the implicit context being set up really helps us over here. So make banana smoothie function, like we just saw, is annotated with the policy zone of being in a banana zone. And since this is an implicit information of the stack itself, the call stack itself, when you call make food and any reads or write operation you're doing, the implicit context is checked, and the implicit context says that, oh, we're in a banana zone. And so we do the appropriate checks. Whereas when you're going through the other call stack, which is via make toast, the implicit context does not say we're in a banana zone. And so we process that differently over here as well. So the thing to notice here is that the implicit propagation actually adds a ton of complexity in itself. And we have to remember that, for example, those of you who are familiar with Python, since most of our examples have been in that, is that you can do async IO operations. So if you want to look at a given request, you would go add make banana smoothie as a task into your event loop in Python, and then it would call make food, and then it would start doing IO to FoodDB. So around this time, the task is going to be paused. And Python is going to look for another task in the event loop that it can process while the IO is ongoing. So it's going to now pick up the make toast task, and it's going to start executing over here. Somewhere within make toast, it's going to, again, hit IO, and then it's again going to pause that, and then it's going to go back and resume make banana smoothie, and so on and so forth. So in the request level granularity, it's much more straightforward, and that's how we also started back in 2020, because you can just have a request level global, right? Your request level global is going to say this has been marked as a banana request, and anytime you want to check the implicit context, you just check the request global, and then you go ahead from there. Here we added the complexity because as you're switching out tasks and resuming, you have to always make sure that you're activating the correct task and resuming the correct task. This is also, again, another thing to note over here is that I mentioned the data can flow check. This is also something that is super sensitive to performance, because you can imagine the number of times a task is being resumed and paused and so on and so forth. And if we make that process, we're adding overhead to that process every time to now save the current zone state, every time when you're pausing a given task. And every time you're resuming a given task, you want to check if there was a zone, and then you want to activate that as well. So that was something that added quite a bit of complexity and getting that right as well. And for us, for example, in Instagram, we also have a lot of services that call into like C++ services. So you're doing a bunch of like FFI and going to other languages and other services. And it's important that we also maintain and this is all within, this is not RPC, right? So we have to maintain the current zone correctly here as well. Not to mention that we also have RPCs being done. And so at Meta, we use Thrift, if you've heard of it. And so we've also baked it into Thrift, where every time you're propagating information that has a current zone, you're also propagating the zone information so that the other side that is receiving the information also activates the same zone. So RPC now is no different from calling a function locally where you have the zone information anywhere in the stack. So high throughput, lots of checks. And like I mentioned, this 58 trillion data flow checks per second is just in one of our services. It's our biggest monolith service, but it's just in one of those. And it doesn't even account for all the task switches that I mentioned where you have to maintain current zone. So one of the biggest blockers or the challenges that we faced was performance and developer experience. And that's why we went through several iterations to the point where a project that we started in 2020 finally felt like we're in a state that we are in somewhat reasonable maturity. Like I said, there's still a lot of work still to be done, but we felt like we finally reached a state of reasonable maturity only in 2024. Performance at our scale, super important, and so is the developer experience. There's another big area that I actually didn't get into that we get into this when we look at different granularities. So if you look at a function level, so if you go back to the make breakfast example, if make banana smoothie like fetches some data from FoodDB that has banana information and it's storing it in some request global for some purpose, then it's, sorry, I shouldn't say purpose. For some reason, it's storing that information in a global. We have to understand that the data has actually leaked from the banana zone. And anywhere in the make toast call stack, you might be able to read the global and access the data. Similarly, if you think of like input that is passed into, say, the make banana smoothie function, if it's passed by reference, and anywhere within the banana zone, if you're mutating that structure, let's say a class object or a container like a list, if you're adding some information pertaining to a banana, and now if this container or list is also accessible in make toast, you also have other types of leaks. So this is a huge amount of complexity here as well. And because of all these different things, I actually didn't get into that in this talk. We have, but we've helped update the type system itself, like in Python and in Hack, we have introduced a read-only concept, a read-only type. We have actually, I might be coming to Pittsburgh. Maybe we'll see, depending on if our talk gets accepted in PyCon, to talk about read-only and how we're using it in our system for this. In C++, there was the development of a deep const. Hack also developed a similar read-only concept. There are other concepts developed as well for these purposes. I see a hand, but I have very little left, so I will get to you.
Yes, please.
And yeah, so and then there's a lot of correctness issues that we have on the remediation front, because today everything is safe only as long as you're staying within the system. Reclassification is a way for us to, it's an escape hatch to go outside of the bounds or the protections within the policy zone system. So it's important that if we just go ahead, and our initial versions in 2020 was just like, oh, we see that, you know, the data has been sufficiently anonymized, or like, oh, instead of going from, like in some cases, maybe it's the banana data itself that is sensitive, like, for example, credit card. It's not important that do we have somebody's credit card information, that Boolean might be desensitized. But the important thing to know is that are we ensuring that the invariants that we started out with when we said, okay, to reclassify are actually being upheld in an automated fashion? Because if we just say that, oh, I reviewed it today, and I think it's okay, and I got like a special review team to say it's okay, and I added the reclassification escape hatch, over time, the code is going to change and mutate. And now instead of returning a bool, if I just start returning the last 4 digits of a credit card, that becomes a problem. And that might not be acceptable, right? So those are the cases where we have to build in like this invariant detection. And this is something we do have cases where we are doing it with automation, but there's still a lot of like flexibility that, you know, teams need. And we're still figuring out how we can scale to some of these problems as well. And then enforcement. We've had a lot of privacy requirements that, you know, touch our systems end to end, but many of them are like they touch a part of like Meta systems. Right now, we're as of last year, we're working on one of our requirements that actually touches every single system, every single data store, all the time. And so now, for the first time, we're going to do something where every asset that I mentioned is going to be doing enforcement. We're just slowly ramping that up, and we are really nervous about how we're investing a lot into a bunch of these early detection tools, early detection systems, and how we can do a lot more like automated rollout of enforcement and automated rollback in cases where we need to make sure that we're not, breaking the entire site as we do this. And yeah, with that, I know there's a lot. I'm going to stop, and I know I went a little over time, but yeah.
No, please do not apologize. This was super interesting, and we asked you a bunch of questions, which you very kindly answered in a lot of detail. This was amazing. Thank you so much. So if you do come to Pittsburgh, please drop us a line. We'd love to invite you for lunch or dinner, whichever works. And thank you again. And I see people can potentially follow up with you also if they want to, explore, ways of potentially contributing or have other questions. So thank you again. Really, really enjoyed the presentation. Thank you so much.
Thank you so much.
Thank you.
It was my pleasure.